Question 3. So we're given this function f that's defined for x is greater than or equal to 0 degrees, but less than or equal to 360 degrees. And it's in this form here. F of x is equal a plus b times sine cx. So a, b, and c are constants, and they're greater than 0. So we're given some information, and we need to sketch this graph. So we're told first that the graph meets the y-axis at the point 0, minus 1, and has a period of 120 degrees and an amplitude of 5. So looking at this bit of information here then, it says the function meets the y-axis at the point 0, negative 1. So if we had a sine graph with no transformation, we'd start at the point 0, 0. So that line y equals 0 would be our principal axis. So we've just shifted that down 1 unit. And we haven't translated the graph horizontally at all, because if we did, then our sine part would be written something like this. Would have like sine c of say x minus some number. Then we'd have shifted it t units to the right if t was positive, for example. Okay, so that means we're going to start our graph at 0, negative 1. So I'll just draw in our new principal axis then, which is going to be the line y is equal to negative 1. So there's our principal axis there, that line in red. And the next piece of information we're going to make use of is the fact that it has a period of 120 degrees. So if we just think of our standard sine graph, y equals sine x, with no transformations or anything, well then the key points on that graph, the maximum and where it cuts the principal axis and minimum, etc., they occur every 90 degrees. So to find that out, we had our period, which was 360 degrees, and if we divide that by 4, well, that gives us our first maximum point, which is 90 degrees. And then if we add another 90 degrees, so at 180 degrees, that's where it's going to cut the principal axis again. And our minimum will be at 270 degrees, and then we get back to where we started at 360 degrees. So for our graph then, well, our period is 120 degrees. So we're going to divide that by 4, and that is going to equal 30 degrees. So our first maximum is going to occur at 30 degrees, and then the other key points on the graph are going to occur every 30 degrees. So at 60 degrees, we're going to cut our principal axis, 90 degrees we're going to have our first minimum, and 120 degrees we're going to be back to where we started. So we'll start plotting some of these points onto our graph then, and we're also going to make use of the fact that our amplitude is 5. So the amplitude just tells us how much our graph oscillates from the principal axis. So our first point then is going to be 0, negative 1. So that's where we're going to start. Our first maximum occurs at 30 degrees, and we have to move up 5 units from our principal axis. So that's going to be at the point 30 degrees and 4. Then we cut our principal axis at 60 degrees, and at 90 degrees we've got our first minimum. So we just have to move 5 units down from our principal axis. So it's going to be at the point 90 degrees and negative 6. And then at 120 degrees, we're back to where we started. So back to our principal axis, and that is 1 complete cycle. So plotting the rest of our points then, well, our next maximum will be at 150 degrees and 4. And then we're back to our principal axis at 180 degrees, minimum at 210 degrees, negative 6. And then back to our principal axis at 240 degrees. So that's our second cycle, and then our final cycle, we're going to have this point here, our minimum there, and back to our principal axis. So now we'll join these points up with a nice curve, and that will be our graph of y equals f of x. Okay, so starting at 0, negative 1, then we're going to come up at our first maximum, down, and there's our first minimum, and then just carrying on. So we come back down, cut our principal axis 180 degrees, cut it again at 240, and then our maximum point and our final minimum point, and then back to our principal axis, and that's our 3 cycles there. Okay, so that is what the graph will look like. So that is y equals f of x there. So now we need to write down the constants a, b, and c. So for a, well, that is just our vertical translation, and we've shifted our graph 1 unit down. So a is going to equal -1. B is the amplitude, so our amplitude is 5. And then C, well, C is going to equal 360 degrees divided by our period, which was 120 degrees, and that is equal to 3. So C is equal to 3. And that is question 3.